All right, well, why don't we go ahead and get started? Thanks everybody for attending today. We're here, I'm Nathan Trueblood, and you're here to hear a bit about real-time analytics and some of our lessons learned, and will your analytics stand up to pressure as you scale your business? So, welcome again, and I'm joined today actually by Nick Sarkisian from HCL. So we're going to be taking you through a tour of real-time analytics together today. So Nick, why don't you go ahead and say hello so we can make sure we hear you. Oh, there we go. Nick, are you there?
Hey, yeah. Hey, thanks for joining us, everybody, this morning. Can you hear me okay?
Yeah, you sound good. Okay, thanks Nick for joining. We'll get right into it in just a moment. A little bit of housekeeping. So today's webinar is about an hour long. We'll go for about 45 minutes. We'll keep an eye on the clock, and then we'll leave some time for questions and answer at the end. So go ahead and ask questions during the presentation, but we'll tackle those at the end. And for those questions that we don't have time to answer today, we'll follow up with an email. So for today's agenda, we're going to be kind of introducing a little bit of how we got here, the current state of real-time analytics. And then really the main focus today is to spend some time talking about some of the early approaches to stream data processing, lessons learned, what we saw from the early days, and what we've learned to teach you today to help you do better in trying to deliver responsive real-time analytic applications to your customers. So that's the basic agenda, and why don't we go ahead and get right into it. There we go. Okay, so a short history of analytics. I've been working in data processing and analytics for a long time. You saw my picture a moment ago. I'm pretty old. So for me, early days began literally with extract, transform, load from magnetic media. So I started the early part of my career as that guy up above loading tapes. And for me, this was loading time series data for energy companies. Big data hadn't been invented yet. It was a very painful process, but thankfully the data volumes were relatively low for the analysis that we were doing. And people were pretty patient. It took a long time to get insight. Now, eventually, as we all know, ETL got easier, storage got cheaper, hard disks got bigger. And the focus shifted a little bit from making structured data and insight readily available, to the business. So now it was easier to get that data. Now we wanted to structure it and make it available. So the data volumes increased, and but we were relatively limited by how much stuff you could store into a single data warehouse. So sort of after the early days of ETL became the age of the data warehouse. And as I was thinking about today's webinar, I was doing some background research. Remember Oracle 10G, Oracle Grid? In a lot of ways, Oracle in the early days, and a lot of folks were trying to figure out, how can we overcome the limitation of putting everything into a single data warehouse? And of course, what brought all of us here today was the advent of fast networking, cheap commodity hardware, and distributed computing is really what gave birth to big data and Hadoop and really large-scale data processing in general. So, the data volumes were comparatively huge, and along the way, we tackled both unstructured and structured data together. But along the way, we also wrestled with a lot of complexity associated with just dealing with distributed systems and the challenge to operate them cost effectively at scale. So that's kind of, short history of how we got to, the era of big data and so forth. The even shorter history that's taken place over that time is that while we've been dealing with greater and greater data volumes, we're also seeing increasing pressure to make good decisions quickly using data. So, with the introduction of technologies like Kafka and Internet of Things, now we're dealing with streaming data too, and trying to make decisions as close as possible to the time of an event that signals some kind of changing customer or business conditions. So everyone's trying to figure out how to be more responsive. Back in the day when we were at Yahoo, kind of during the peak, there was constant pressure to produce insight more quickly. What was trending yesterday? What was trending over the last hour? What's going on right now? This is particularly acute for the advertisers and the cloud guys because, advertising use cases and content personalization, the difference in being responsive can mean the difference between millions of dollars in lost ad revenue or lack of customer engagement if the content you're serving them is stale. So the race was on to be more responsive, and now we're seeing use cases for real-time analytics are expanding, and we're seeing new examples every day. It's actually what's kind of exciting about working in big data is we still haven't found the limit of what's possible, especially as we take in and start looking at more and more real-time use cases. So ultimately, this is what led many technologists like us to realize that we reached the limit of what we could do with batch processing alone, and we had some challenges in the big data systems in general. Businesses figured out that they're loaded with valuable data. And Hadoop helped unlock a lot of the insight in that data. Now we're learning how to run with that data. So, kind of like the guy up in there in the picture, now businesses realize to stay competitive in 2018, you're in a race to be responsive with more data than ever before at the speed of machines. And if you look at what's happening in the market around machine learning and artificial intelligence and all the exciting innovation that's going on there, to some extent, we're all racing towards a world where all the decision making is being made by machines with humans in supervision. So that's kind of where it's all going. And I think the other comment I would make here is what, and this is something Nick and I were talking about the other day, was that we're seeing in the field that more and more customers are trying to figure out what insight can be produced from data before it even hits the data lake.
Yeah, absolutely. And Nathan, sorry, I got muted on the WebEx. Can you hear me okay?
Yeah, we hear you great. Thanks, Nick.
Okay, good deal. So I was unmuted on my phone, but muted on the webinar. Yeah, so Nathan, you bring up a good point, right? And it's something that we see, have conversations with customers, on a weekly basis around. There's so much analytics and predictive modeling and machine learning that's happening in a data lake out of a batch process. But it is, what we're starting to see is people are looking to see the value in running analytics before it hits the data lake and before it goes into the analytics machine, if you will. And there's an opportunity to create use cases that leverage machine learning and advanced analytics with data in motion, if you will, as it's sort of being streamed in. And, use cases like contextual offers where customers have been, searching online for a specific product, that goes, you can track that, you can do analytics on that to know sort of what they're looking for in more of a batch process. But then leveraging location-based real-time information to look and see where those people are. Are they close to a store? Are they close to a place where a contextualized offer can be served up on that specific product to try to get them to either buy that product now or actually use your service to purchase a product? If we were talking financial services, it could be a car loan or insurance or whatnot. So the use cases are starting to pop up, and people are starting to look at if we can analyze and run models against this data while it's in motion and before it hits the data lake. What sort of use cases does that enable versus having to wait for data to reach the central repository before we can start to combine and analyze it?
That's exactly right. So we're seeing that pressure and that expansion of use cases, just as Nick is pointing out. And as people move beyond kind of the early use cases, we're also seeing that some of the resulting architectures, have led to failure. And of course, everyone talks about, this Gartner prediction and commentary about, big data and Hadoop has failed us. But I think it's really more that complexity in IT, continues to be a challenge. And so, in the early days of streaming analytics and fast data and stream processing, it was pretty uncharted territory. And we really didn't have a lot of previous experience or examples to guide us. I think how this came about in the early days, Hadoop helped to show the way, but there was a lot of inherent complexity in developing applications for in-memory streaming analytics that could produce results at scale. we had kind of in the early days some use cases and some technologies that solved very specific problems. So, examples like this include technologies like Apache Storm, or at Yahoo we had something called S4, which is a simple, scalable streaming system. Some of the early versions of Samza and other technologies like that, they didn't have a lot to go on, so they were groundbreaking, but they're also showing signs of strain as we push the use cases further. Another example of this, and there's still a lot of debate about, of course, is the Lambda architecture, which you can see here. So Lambda was an attempt to kind of introduce data in motion, streaming data, streaming analytics, into the mix where data at rest is already being processed at batch. In theory, this is a good idea. It kind of keeps two very separate systems, two separate approaches, separate from each other, with the idea of trying to reduce complexity. But in practice, for a lot of companies dealing with data at scale, it also created a lot of complexity, because now you had two completely separate paths for processing data, two different code bases that you were dealing with, and so required even more from your architects and developers to deliver things successfully. So now there's nothing inherently wrong with these approaches. The point I'm making is, these are all based on kind of limited experience. It's like the silly comic I have on the slide here. We really didn't have a lot of prior knowledge to base our diagnosis and treatment of the problems we were seeing. So we did the best with what we knew. Now, another thing that we see happening along the way here is not only are we sort of wrestling with complexity, but customer expectations have shifted in the last few years as well. It's as if it wasn't enough of a challenge to try to deal with sort of marrying real-time and historic data together and issues of scale. The customer expectations have shifted. Now customers expect more from businesses that serve them. So they kind of expect, and Nick's example of a contextual offer while you're standing in the store, is a good example from retail, where customers kind of expect you to know everything about them, to know everything about your changing business conditions, and to use that knowledge based on what you know about your customer and your business to empower them and let them be engaged in how they deal with you. So this isn't just, everyone likes to point to examples from retail because those are really easy to understand, but it's not just retail that's dealing with a new kind of customer expectation. We're all expecting this of businesses and service providers that we deal with, especially the ones who are dealing with scale. So the challenge for business in 2018 is, how do we meet this expectation? Because not meeting this kind of customer expectation can mean the difference between success or failure of the business. So how can we be more responsive in real time without breaking the bank as our business grows? So to me, this is the essence of what people mean when they start using buzzwords like digital transformation and all those things come out. It really comes down to, how can I be more responsive to my customer at scale and not break the bank?
Exactly. And this is something that we see again in the marketplace and from our customers on a daily basis almost, is the idea of, how do I anticipate my customer needs? How do I know my customers at a deeper level? Those are all the driving factors behind the digital transformation message that we go in with, and what our customers are asking for, right, from an enterprise level. So the analysis and the ability to anticipate customer needs and understand what's driving customer purchase behavior and being able to interact with them on a real-time basis, I think is going to be something that over the course of the next 2 to 3 years, more and more of this decision making and more of the interactions and the anticipation of customer needs will happen via real-time data and through running analytics on data that's actually in flight and maybe not in the larger data warehouse yet.
That's right. And so all of this kind of sums up to a lot of new demands are being put on the business in 2018. All these new demands, the need to compete, it's putting a lot of strain on some of the early approaches to stream data processing and stream analytics. So For the rest of the presentation today, really, I'm going to focus on some of our observations and learnings about the challenges of the early approaches, and where customers, at least the ones we deal with at scale, are seeing signs of strain. Now, a little bit of a disclaimer, we've only got an hour today, and as you can see some of the technical challenges I've listed over on the left, each one of those could be the subject of an entire hour's talk. So I'm going to kind of surf the wave tops here and help at least sensitize you to some of the challenges and concerns, and at the end we'll talk about how some of that can be overcome. The goal here is to share our perspective and our experience in the hopes that it's going to help you in your journey in getting more competitive and tackling the real-time analytics problem. So for many businesses, the early solutions are working just fine. If it's not broken, of course, don't fix it. But where we're seeing a big problem for companies dealing with stream data processing and analytics are those businesses that are in industries that are simultaneously dealing with large scale or growing scale cost pressure and the need to deliver new products and services quickly. So there's a lot of things coming at the business right now. And so that's showing up in what we see in terms of adoption and interest in the industries that are applying stream data processing and analytics. So you can see them there. Retail is a big one, but financing and banking is another big one. Communication service provider. All these guys share the common trait of dealing with a massive customer base whose expectations have shifted, and they're trying to engage with those customers with new kinds of products and services all the time. So it's putting a lot of pressure. So, these are the kinds of customers and industries that are coming to talk to us, either because they've already had some kind of a failure with how they're delivering streaming analytics, or because they're seeing failure on the horizon as the use cases are piling up, and they're like, well, we managed to deliver a couple of use cases with what we had before, but we see trouble on the horizon. So to me, it's a little bit like visiting a doctor and receiving sort of generic treatment that's only dealing with the symptoms. Let's talk about some of the symptoms and their causes, and that may help you understand sort of where the underlying problem is and what you could do about it. So one of the challenges is that we see from some of the early systems is resource management and low utilization. We see this a lot in customers who chose early approaches to streaming analytics. We see this in customers today where one of the symptoms, for example, is purpose-built clusters for a single use case, or where utilization of the infrastructure is relatively low. Now, if your use case is small and your data volume is low, well, that's not a big deal. But if you're in one of the industries I mentioned before, this can be a killer. So at the time that a lot of the early systems were developed, most of the resource management systems weren't very mature or weren't up to the task. And when I mean resource management, resource utilization, I mean how much value are we getting out of the cluster and the distributed system? Because quite often we're talking about hundreds, if not thousands, of computers that are powering these kinds of analytics and experiences. So, there wasn't a lot of choice to the early developers of streaming analytics in terms of mature distributed resource managers. So the early developers were forced to address the challenge of delivering not only the functional aspects, how do you describe the streaming analytic application, but how to process the data and so forth, but also they're mixing that with the operational concerns. How do we scale as the volume increases? How do we deal with failure and so forth? So as a result, developers who use a lot of these earlier systems, the sort of first generation architectures, are required to deeply understand how these systems work in order to get the most out of them. So you have to be worried about how is all of the work being scheduled onto the cluster, how is all that inner working taking place in order to be able to use the system effectively. And this isn't unique to streaming analytics. You see this pattern kind of repeated in almost every emerging technology. In the early days, the developers are forced to take a pretty long road to get value out of a new approach. Over time, the technology matures, the abstractions get better, and a cleaner separation emerges. So there are a bunch of examples that illustrate the point here. You can see them over on the right and read about them later. Librado ultimately decided to replace Storm because they had challenges related to utilization, cost, and complexity as they scaled. And ultimately, I think Twitter did the same thing. Even Hadoop in their early days when it was 1.0, we really delivered 2.0 and Yarn as a major architectural rewrite in response to the trade-offs we've made around resource utilization. So a big reason for the push to Yarn, which was a more modern, more mature resource scheduler, was that at Yahoo scale, the low utilization, over provisioning of clusters, purpose-built clusters, was hugely expensive. And so ultimately, Yarn was partly about trying to get ahead of that expense. Another big challenge that we see and this is, customers coming to us who are wrestling with this problem, comes down to data integrity and reliability at scale. So, the big challenge here for early streaming solutions was maintaining data integrity and overall reliability while still preserving some kind of adequate performance as load increases. So in the early days, losing a few bits of data here and there, it's not a big deal if we're talking about what's trending now on Twitter. But this can be a big problem if your use case depends on the integrity of your data and ensuring that you can deliver correct, repeatable results. So in streaming systems, processing guarantees is a big one here. And what it really means to me is making sure that you know what data you've touched in what order, and you can guarantee a consistent, repeatable results. So early systems were a little bit more concerned with being able to solve a use case at all. And a lot of the considerations about integrity and processing guarantees often came later or were left as aspects to the application developer to tackle. Again, not necessarily unique to streaming, but a common pattern that we see. So it's not surprising, but it can become a big obstacle to delivery into production if your developers also have to handle all the features required for integrity, fault tolerance, and so forth. And furthermore, the approach your developers take from one application to the next can vary dramatically as a result of, and as a result, DevOps teams may struggle to deal with sort of a patchwork of different approaches to dealing with reliability and data integrity. So,
and Nathan,
go ahead, Nick.
You bring up you bring up a really good point here too, right? I think it's worth noting that for some of the customers that we work with, when it comes to the scaling piece of it, when it comes to the data integrity, the reliability, trying to program for a specific infrastructure for some of these streaming things, generally what the trend that we're seeing is when they have, 3 or 4 PhD or super high skilled developers working on, some of the science experiments within a small group, trying to do POCs and sort of test the waters. The data and scale of the applications are limited. The number of touch points are limited. It generally works pretty well. There isn't a whole lot of friction or issues that pop up. And it's a little bit of a veil over the real problem, because they have this experience and they look at it and they say, okay, this model will work. The architecture will work, and as we move forward, this whole approach, we can just take it and scale it. And what ends up happening is, as the development team scales and you go from 3 people to 30 people, not everybody is able to program at that level, right? The pyramid of skills just doesn't work that way. And so what ends up happening is you run into a problem where the patchwork and the troubleshooting that has to happen for all this code, as we start to scale it out to more people working on it, becomes a huge hurdle for moving applications and developing new applications in a production level environment. I think one of the other pieces is just from an overall scale, as the data becomes larger and the applications become more robust, the complexity that is driven into these applications and into the infrastructure and into the architecture, again, provides a hurdle that, when trying to support a production level application with that level of complexity and sophistication, it really hampers what they can do. So, the science experiments all work great. The architecture doesn't so much matter when you're dealing with some of these pilots or POCs. As you take a step forward and start to look at productionalizing applications and using streaming data or streaming analytics for real use cases, the architecture starts to matter a lot more. And certainly when you look at the people side of the equation, having an extremely complex architecture to develop against does not support a model in which you can scale out the development.
That's right, and and if you agree with the point I was making about earlier about the the sort of the kinds of customers and their size and the industries they're in, they have to think about scaling the technology as much as thinking about scaling the teams. And an example of this, from one of the early winners, which is Storm, is that when you try to turn on data integrity features, you end up with some challenges. So when you turn on processing guarantees in Storm, for example, as data flows through the system, each step has to emit an acknowledgement that they got the data. That way data loss can be avoided if you have a failed acknowledgement. That works fine in theory, but as an example from Loggly illustrates, in the case of Storm, as your data volume increases, the acknowledgement mechanism introduces a performance penalty that increases exponentially as your volume goes up. So, it wasn't really a bug. It's so much that it was a limitation of an early architecture. So some of the customers that come to us have realized they, are in a situation where maybe they have to start over. Another one that's fun to talk about, of course, is the Apache S4 that we created at Yahoo. I love in the description that it's S4 is described as partially fault tolerant, which is kind of humorous. What they're really saying is, look, it lacks a mechanism for reliable data delivery. So that's fine. It wasn't designed as a system to reliably deliver data. That wasn't its original purpose. So you get the idea. This is a big one, and it's something you have to look at carefully when you're looking at delivering not just one use case, but a lot of use cases in your enterprise where integrity and reliability at scale really matters. Now, of course, related to this is another big one, which is operability monitoring, debugging and tuning. We see that again with early tech, and in particular, we see it with early streaming systems. It's lack of tooling and integration points that help you when you're going to production deal with debugging and tuning and optimization. And you may end up discovering the hard way that when you're ready to go to production, you don't actually have what's needed to take the science experiment all the way to a production win, which is tools you need for monitoring, root cause analysis, diagnostics, and so forth. Let's be fair, debugging, tuning, and troubleshooting distributed systems at scale is a really hard problem. And this is probably why we see such an explosion of tools and companies that are focused on dealing with application performance and system reliability, especially in the age of cloud computing, which is just amplified the whole challenge of distributed computing in general. So it's not a surprise that early streaming systems did not put a lot of energy towards operability, since again they were just trying to solve a use case in the first place. And so operability ends up being kind of a can that gets kicked down the road in IT. But I would also argue it's probably one of the biggest reasons that so many big data projects sort of fail to get to production and then across the finish line is because these sorts of features weren't designed in from the beginning. And if you have to go in and retrofit them, first of all, no one wants to do that, and it can be very difficult, to add features that you need for, operability and monitoring. And oftentimes you may discover the architecture of what you're dealing with is opaque or very difficult to trace. So you may, in fact, be prevented from being able to, detect or prevent a failure before it even happens if you can't inspect and see into the system that's delivering the analytic applications. And there's some more examples you can see there. For example, if you look at what Spotify did, they were an early user of Storm. They had to build a lot of stuff on their own around Storm in order to deliver it as a production-ready system. All right, and then lastly, and I think this is probably the biggest one of all, comes down to development complexity associated with delivering streaming applications, especially based on early architectures. In my experience, nearly every successful software development innovation comes as a result of a powerful abstraction that hides underlying complexity and makes the developer, more productive. So if you think about it, the complexity in streaming analytics comes really from the previous three things we've been talking about, which is developers have to understand the resource management aspects in order to know how to write their application. So they have to sort of know the entire architecture top to bottom. When we think about data integrity and processing guarantees and things like idempotency and resilience, those are often left to the application developer to implement. That's the sort of S4 partially fault tolerant comment I made earlier. So, you know, it's a lot for the developer to have to deal with. You know, would you be okay dealing with a database that didn't meet the ACID standard for consistency, for example? You know, if you had to write all of that as part of your database application code, you might just say, well, forget it, or, you know, be pretty limited in your use there. So it comes down to you can't improve what you can't measure. So either a developer has to fully focus on instrumenting their application, which takes time, or you decide to fly blind, which can be a huge problem later when you start to scale and can't explain or predict failures. So if you think about it, this is really what results in early systems being difficult to use. It also explains why simplifying abstractions tend to catch on like wildfire. It's because it makes the teams more productive. It deals with the staff scaling problem that Nick was talking about earlier. You know, and so it's easier to scale. It also helps to explain the attraction of the cloud providers today, because they hide a lot of that complexity and provide that tooling as long as you're willing to be locked into their infrastructure and write large checks. So, you know, cloud is great because, again, hides that complexity. But for the kinds of businesses we're seeing at scale, cloud is not a silver bullet. So you get the point. I think this is really the, you know, probably the biggest killer of customers that we're seeing today dealing with early streaming systems. You know, for many large enterprises where the data is just too important and valuable to hand over to the cloud guys, there has to be a better way. And so, you know, that's where you need to look at later generation, you know, streaming architectures and systems. So, of course, not surprising, what should you do about it? From our perspective, you need a treatment, you know, proper treatment that kind of builds on what was there before. And you also need, you know, a specialist who really understands, you know, the history and the challenge and what we need to do to get there. So I'll talk a little bit about our product. Now, of course, there's other things that are out there, but of course, this is a DataTorrent webinar. So, you know, I want to tell you a little bit about how our streaming analytics product helps overcome some of those challenges. You know, first of all, we developed our product as a second generation. We were really looking at overcoming a lot of the limitations and challenges with early streaming analytic applications, early streaming analytic you know, approaches and abstractions and so forth. So, you know, our platform, which is DataTorrent RTS, is that next generation system. You know, it tightly binds fault tolerant, you know, streaming and analytic processing with Apache Apex plus, you know, CEP rule engine that we've made fault tolerant from Drools, you know, and also supports a variety of, you know, real-time machine scoring models. So, you know, RTS is a platform that really is that next generation. And furthermore, we've also wrapped it with something I'll talk about in a minute, which is our epoxy framework, which is really, when you think about it, it's all the stuff you need to wrap around the technology to get yourself to production. So, you know, our epoxy framework is the diagnostics, the metrics, so you can understand how to instrument your application. It's the monitoring and integration. It's all that stuff that is oftentimes considered boring when you're just trying to deliver the use case, but it becomes really important when you're trying to get to production. So oftentimes getting to production, 20% is solving the problem, 80% is dealing with operability and production readiness. And that's what our epoxy framework, which is part of our product, helps you do. And then lastly, we have an application factory where we make patterns and applications available to our customers that are hardened and pre-tested and based on experience in developing these applications for customers in the market today. So again, you don't want to start with a blank piece of paper. If you can start with a pattern for an application that you already know works, that's a much better starting place. And so our application factory is there to help our customers get started faster and get to production outcomes more quickly based on best practices that we see in the market. So that's the treatment. But it's not enough to just simply have a product. You also need a strong partner who knows what they're doing. And so, Nick, you can talk a little bit about HCL's involvement with DataTorrent and what you guys bring.
Yeah, sure. I was just waiting for the slide to pop over. Yeah, so HCL, I don't know how many of you on the webinar are familiar with HCL and sort of what we bring to the table, but essentially our relationship with DataTorrent is twofold. We're one of their primary partners for real-time analytics. So from an implementation and use case perspective, we work jointly with them on a regular basis to define use cases, talk to customers about approaches. But I think we also believe that the DataTorrent product, especially with the Apache Apex model, is the way that streaming will move in the future. And so the other part of this is that in many of our reference architectures, or actually all of our reference architectures that have a streaming analytics component, we have actually incorporated the DataTorrent product into our architecture as best of breed. Now, obviously, some customers have other sorts of thoughts or may have invested in something already. So, we sort of we'll work with that. But as a starting point, DataTorrent is definitely the, sort of best of breed in that place. I think the other piece too of this is we also have a significant amount of people trained in creating DataTorrent applications. So one of the applications that we're creating that'll be hopefully available on the DataTorrent marketplace here shortly is a transaction credit card fraud analytics app that will actually use a machine learning model to monitor the transactions in real time and to create fraud alerts and actually learn the different transaction patterns as it goes in real time as that data is streaming in. So it's something that we're working on from a DataTorrent application and something that should be available for sort of a POC kind of thing over the next few weeks or a month.
Yeah, so we're working closely in the market, and I think part of what brought HCL and DataTorrent together was a shared recognition and experience with some of the challenges and failures that customers were collectively seeing with some of the early approaches. A little bit more about DataTorrent's product. Again, I'm not going to focus the balance of the presentation here today, but from a product and technology perspective, as you can kind of see mapped in these different colors, there's a bunch of things we've done in the product to directly address the challenges that I shared with you today. So for example, our application factory, we've developed hardened pre-built application and components that saves time, gives you best practices. Our platform provides all the sort of deep inspection and tooling for testing and tuning and optimization, and that's above and beyond what Apex provides. It's all the stuff you need to wrap around that epoxy stuff I was talking about before that makes it easy to diagnose and tune and troubleshoot. And then, of course, because we had the shoulders of previous generations to stand on, we also were able to think about proper separation of concerns and simplicity. So data integrity and fault tolerance, those aspects are provided by the product, by the platform, and not required that the developer implement all of that in order to get application resilience, system resilience, or data integrity. I mentioned earlier we integrated with Yarn from the early days for a reason, and that was because it provided everything we needed to handle the management and scheduling of the cluster, and that way we could get high utilization. And then over on the right, certainly integrity was designed into Apache Apex from the beginning, that you could have processing guarantees, checkpointing, and data integrity without having to sacrifice performance. I would say that was probably the biggest challenge that the team dealt with in the early days of developing Apache Apex, was how to continue to deliver with performance, with volume and low latency, and yet not have to sacrifice data integrity. So another point I would make here is, I kind of threw some rocks at the Lambda architecture. Again, nothing was wrong with Lambda in particular. It was a good architecture, and for some businesses, it's the right architecture for their use cases. We would argue, of course, DataTorrent and Apache Apex in particular is a Kappa architecture. It was done right with HCL's help. You can reduce development complexity because you can avoid maintaining two completely separate code bases and sets of expertise. So, ultimately, this helps with both data integrity, reprocessing problem, as well as not having to maintain two completely different code paths and sets of expertise and teams and understanding. Again, there are a lot of cases where Lambda makes sense, but in the case of DataTorrent, we've sort of looked at that architecture and moved in beyond it and implemented Kappa in our solution. So I already talked about this a little bit, which is our epoxy framework. I think a couple more points I'd like to make here about it. It really is recognition that 80% of the problem in getting to production comes down to not Apache Apex or Storm or any of those other technologies. It really comes down to all the stuff you have to wrap around it. Regardless of what abstraction you choose, and of course we'd love for you to choose Apache Apex and DataTorrent, your success or failure really depends on a lot more than just a compelling technology or an abstraction. So in our experience, without something like epoxy, your best, the best you can really hope to achieve, just grabbing open source off the shelf, is a really compelling proof of concept and a long road to get to production. We get excited at DataTorrent when our customers get into production and their applications start making a real difference for the business. So Nick, you covered this a little bit earlier on. Maybe you can tell us a little bit about HCL's team here that's really focused on analytics use cases.
Yeah, sure. So I think actually if you can go to the next slide, I think just for the sake of time, because we're getting a little bit behind. Yep. So I just wanted to give everybody a sense of the HCL Analytics practice as a whole. So globally, we're about 6,000 people. We have multiple offshore delivery centers and on-site delivery centers. We have large COEs that are focused on really a number of different areas across machine learning and AI, predictive analytics, big data, and more specifically on real-time and streaming data and analytics. And that's where the DataTorrent piece fits in, is again, we look at these problems holistically from an overall architecture and technology point of view. Our starting point is always around the best of breed technologies as part of our reference architecture. So while we do a significant amount of work with DataTorrent, and that is our sort of go-to standard, DataTorrent for us is just a piece of the puzzle, right? It is not the, it's filling a very specific use case and a very specific need. And as mentioned earlier, I think we're seeing that need grow day by day in the marketplace, which is something that we're both very excited about. But it is a key cog in a larger analytics landscape. So that's just a little bit about HCL. Here you can see some of the analyst ratings. So it's not just Nathan and I sort of tooting our own horn here, but you can see sort of from some of the Gartners and IDCs, Forrester, Everest, that HCL is a global leader in analytics and specifically around real time and big data. So I think with that, we're right at a 1:45, Nathan. So why don't we turn it over for questions, and we can answer any questions people might have.
Okay. Yeah. Let me wrap up, and then let's go to Q&A. We're running just a couple minutes behind. Thanks, Nick. So really summary today. Again, like I said, too short a period of time to go deeply into all of the challenges. But in summary, what we're seeing is that customers, particularly ones that are working at scale, our recommendation is you need to sort of embrace a new market reality, which is all around, fast data, producing insight before it hits the data lake, real-time responsiveness, and trying to meet customer expectations. So, if that's kind of the reality you're facing in your business, then, learn to recognize some of the signs of strain, right? Which are the ones we talked about earlier around, are we getting the best utilization out of our people and out of our infrastructure? Are we getting the kind of data integrity and reliability that we need? And are we able to deal with the complexity so that we can respond quickly to new opportunities? So, the ultimate recommendation here is you need to think about how to stay competitive. So, choose a next generation streaming architecture if you're seeing some of those challenges, and seek trusted expertise from a specialist with experience. So in other words, you need a plan. So part of today's webinar, and we'd like to encourage you, if some of what we shared today resonates with you and what you're seeing in your business in 2018, please contact us. DataTorrent and HCL will sit down and essentially do a free health assessment, right? Thinking about 2018 and the new year, and this is the time everyone takes New Year's resolutions. So, let's spend a little bit of time together, no obligation, and sit down and do a health assessment and look at some of the challenges that you're seeing in your business. If it looks like we may have the answer to help you overcome some of those either looming problems or failures you've experienced already, we're prepared to provide a free software license to help you get there and try it out. And together with HCL, we'll recommend essentially a personalized treatment plan, which looks at the approach you're taking today and make some suggestions about how you may want to upgrade or think about doing things in a different way so that you're ready to compete. So now why don't we go to a little bit of Q&A. We're not going to do it live. I'm just looking at the questions that have been posted. So if you have further questions, go ahead and post them into the webinar now. So one of the questions from the audience is, how do you address challenges with integrating cloud with low-level architectures for real-time analytics? So it's a big question, so we'll kind of break it down. So a few things. So sort of cloud integration agnostics has to be planned in. Your solution has to include connectors to the cloud ecosystems that you're dealing with. So in the case of DataTorrent, we've got a whole library of ways to get data in and out of Azure or AWS, whether it's Kinesis or the Azure Event Hub and so forth. Also, again, you have to, even though you're dealing with the cloud, you may need to think about cloud agnostic approach to things. So again, this means you may have to think about making sure that your solution is going to be able to work on premises, where maybe you're dealing with sort of, I'm not sure what's meant by low-level architectures, but where you're dealing with perhaps higher volume, faster data coming from low-level architectures. I must be referring to IoT. So you may need something on premise, and you may also need to think about how you're going to deliver that in the cloud. And the point that I'd like to make there is you have to think about the operability concerns in both places. So don't just assume that because you're going to the cloud, you're going to get the same operability both on premises and in the cloud. So you kind of have to think about designing that in from the beginning. So again, there's probably a lot behind the question. So please do contact us. Would love to get more into the details behind the question. Another question I see here is, it says, as more people develop and access these new applications, do you see hurdles from a security standpoint with what seem to be ever-growing privacy regulations? And so the answer is absolutely. We see hurdles there, and so I would say, first of all, we build a lot of that into our product from the beginning. So, for example, security integration is required for the enterprise, but you also have to think about data privacy, and that can come down to encrypting the data and being able to process the data, in motion, even though it's encrypted. And we have solved use cases like that for customers today. And there are a variety of approaches to doing that depending on what kind of privacy concerns you have. The other big aspect there from a privacy perspective is that we see commonly is the need to be able to track the lineage of every bit of data that you touch. So we see that in almost every customer environment that's dealing with sensitive customer data, there is a requirement to address essentially regulatory compliance, but really it comes down to address the fact that you have to be able to prove who touched and modified a particular piece of data to produce a result. So this is where, again, epoxy comes in. We've got supported integrations with data lineage, tracking systems that are provided as part of, either your enterprise or as part of the, your existing Hadoop distro. So that's another area where, again, the use case might be 20% dealing with the data privacy concerns, governance, security, lineage tracking. All of that is what we think of as part of our epoxy framework, which is making the open source enterprise ready. All right, looks like not a lot of, one more here. So one of the questions here is, does RTS have any visualization tools with streaming analytics? And the answer is absolutely. A big part of being able to understand both the business aspects and the operational aspects of a streaming analytic application comes down to being able to see. So earlier I mentioned under monitoring, debugging, and operability, you can't improve what you can't measure. And it's oftentimes helpful to be able to see what you're measuring. So we have a complete facility for visualizing data in real time and producing pretty rich dashboards. So that's just a convenience to application developers who are writing streaming analytic applications, where ultimately the deliverable might be signaling some kind of an event or insight, but being able to see how well that application is working, being able to drill down into the data, and being able to drill into the operational aspects, those are all the things that you need to deliver a complete application to the business, as well as to be able to sort of see and operate at scale and understand the performance characteristics of your applications. So, an emphatic yes is the answer to the question. And I should also note that we integrate quite frequently with other visualization systems. So as much as I would like to think of us as the center of the universe, quite often what you're doing in streaming analytics is producing real-time visualizations, but you may also be preparing and delivering analyzed data to other downstream systems. Tableau is a good, notable one, where you maybe want to look at your historical data and provide some kind of roll-up and reporting to executives and so forth. So with that, it looks like there's not a lot of other questions coming in. So I'll finish with one last slide. I don't expect you to write all this down. We'll make this information available to you after the webinar. But here's some resources. But in particular, if you're seeing some of the challenges in your business that I highlighted earlier, or you're trying to figure out what's the right way to start being more competitive and respond to changing customer expectations and business conditions, please contact us. There's an email address down below there. We'd love to sit down, talk through the details of what you're seeing, answer your questions and so forth. And if you're interested, we'd love to see if we can help. So thanks again for joining today. Thanks, Nick, for helping out and being a part of this. And give us a shout. We'd love to help. Happy New Year, everybody. Thanks for joining.